I remember crying in high school when it came to linear graphing because I just didn't get it. This game, which I made in 2018, will help take you from plotting basic linear graphs all the way to complex quadratic equations, hopefully with a lot fewer tears. The game's called Penalty Shootout, and what you can use is either a printed linear graphing axis, which is write on and wipe off, or you can use the Think Square kits, the transparent overlay here, with some rubber bands and tokens for the ball and the players. So the aim of the game is to score more goals than your opponent, and you'll rotate between being the striker, the person who shoots the ball, and the goalkeeper. We'll begin with the most basic starting position, where the striker starts at the point 0,0 and the goalie starts at the point 0,6. What this means is, whenever the striker shoots, instead of being y equals mx plus c, the equation will just be y equals mx, because the c part, where they start on the y-axis, is 0, so there won't be anything there. So all they need to focus on is the gradient. And so to take their shot, the striker either verbally says to the goalie what they're going to do, or they write it down somewhere. So let's imagine y equals 3x is the equation that they want to kick along. Now the goalie gets 5 to 10 seconds to react. The better the goalie, the less time you give them. And you can also adapt the size of the goals for the striker. So if you've got someone who's not very good at shooting, you might make that a little bit wider for them. So the goalie reacts, they can dive 1, 2 or 3 units right or left. So let's imagine they just dive this way. If the ball is less than 1 unit away from the goalie, they will stop that. If not, the ball goes through. So the ball will go through this point here if there was just a y equals or x equals 0, that would be straight up there. Now, we have to calculate this. So what we're going to do is do that with beads. So this means that y is 3 times whatever x is. So the x coordinate here is 0, 3 times 0 is still 0. If the x coordinate was 1, the y coordinate goes to 3. If x is 2, 2 times 3 is 6, and that goes through the goals. And now if the goalie was there, they would block that, but they're not. So that will go through, and we can just continue the line if we want. And you can also, if you want to, put a rubber band there just to see what the pattern will look like. But we can see that that's going through. Now, just to confirm, if you hit the post in this game, it goes through. So if we had y equals 2x, we'll just change that equation really quickly. So y is equal to double what x is. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 6. And so that counts as going in. It will bounce off the inside of the post and go in, just so you know. So there's no debates later in the game. So that's the starting position. Players would then swap, and the goalie would become the striker and vice versa. And we're going to do like a penalty shootout, see who scored the most goals in that time. Then we can ramp up the complexity. So we've gotten the gradient sorted out. In fact, actually, before we ramp up the complexity, if the goalie sees that the person they're playing against is always kicking to this right-hand side because they only can use positive gradients, they might just dive this way all the time. So they've got a very good chance of stopping the ball if they're diving. They've got a 1 in 3 chance probably, or even more, of stopping that ball. So then what might happen is they learn, oh, well, actually to get a ball to go this way, well, they need to start thinking about how would I get a ball to go this way? And so now we're talking about negative gradients. So here we might have to have y equals -3 to get the ball to go that way. And that's important because now we've learned a negative gradient goes in that direction and a positive gradient goes in the other direction. Once we've mastered that, we can start adjusting the intercept. So still keeping the goalie and the player a consistent distance apart. We might then make them go at the position 3. So we've moved them 3 units up, which means we need to move all of this 3 units up. So it'll look something like this. And this is exactly the same as before. However, we are now starting at the position 3. So if we rub that out, so if we think about y equals mx plus c, we know the starting position where the striker is 3 units up on the y-axis. So we can automatically put that there. If we get that wrong, if we say +2 or something, then we're kicking the ball from the wrong spot, so we won't score a goal. And if we try to kick it, let's say we tried to kick it, y equals x plus 3. So this time we're just looking at the x coordinate, then adding 3 to it. So y equals x is 1, plus 3 is 4. So we're going there. And then if we go to the next one, y equals 2 plus 3 is 5. And you can see this pattern eventually is going to get to the goal line and it's definitely not going in. So the goalie doesn't even if the goalie dived in the wrong direction, that would still go through. Wouldn't go through and there would be no goal scored. So the players need to be careful that they're shooting in the right direction to make sure they score goals. We can continue increasing the level of complexity by moving the goalie to the right or to the left of the striker. And now we're working out our gradient by doing the rise over the run. So if we're going to run 6 or we might even run 8 and then rise 2 or something like that. So here, this equation here is going to be 1 over 4 because we're rising 1 for every 4 we're going across, and I'll show you that by looking here. So if you think about where we were, we've kicked it 2 units up, but we've kicked it 8 units across. And so here, the rise is 2 and the run is 8. 2 divided by 8 is the same as a quarter because you can see here it's also gone up 1 and across 4. So this would be y equals 1/4 x plus 6. So the starting point is 6. Oh, it's actually 5. The starting point is 5. And we've gone up 1 unit for every 4 we've gone across. Now, because this passes through the middle of 2 spots, if the goalie had dived here or here, they would block this shot because it's within 1 unit of their reach. So either of those spaces blocks the shot. So if you can, it's better off to kick your ball right through an integer number because then the goalie only blocks it when it lands on that space. So you're giving them a less of a chance of doing it. So we can increase the complexity again by allowing the goalie and the striker to go anywhere they like. So now the striker might even go off the intercept and it's going to be a bit harder to calculate now. And so they might even try to take a shot that goes through here, or maybe they'll go like that. So they know they've got to kick it across 3 and up 1 to get through here to make it a nice easy intercept to do if they want not to work with decimal numbers. So again, we're going to go across 3, up 1 there. So that's where we're going to end up kicking it straight at the goalie. But if the goalie dives, like in soccer, when you kick it straight at them, if they dive out the way, it goes through, so too bad, so sad. And then we can get crazy complex with quadratic equations. So y equals x squared minus 8. And that ball will travel like soccer on a bit of a curved path. You might even get really complex and put a series of 5 or 6 defenders out on the pitch and see if the striker can work out a pathway to score a goal. Here it would be y equals x cubed.